All right, so today we are covering what really could be called uh, a lecture before lecture. This is an important topic, but to be clear, it's not the topic. The topic is going to be on Thursday. And Thursday is one of my favorite lectures to give. If you have the capabilities to be here in person, it would be a good day to be in person, just because it's kind of more fun to be in person for that lecture. We're going to be talking about test-driven development, and it does, I don't know, it hits better whenever we're there. So today we have to talk about what testing is, what it accomplishes, just so that we're able to do the test-driven development lecture. So it's kind of, like I said, it's not the lecture, but the lecture before the lecture. But there is something that's going to happen at the end that's going to be worthwhile. We're going to kind of explore a JUnit inside of Eclipse. So if you want to go ahead and open up Eclipse if you haven't installed. If not, yeah, Eclipse is what I'm going to show it off of because it's free and installed everywhere. IntelliJ has the same stuff built in. I just don't remember off the top of my head. I can't give you the menu for IntelliJ off the top of my head. It's not my primary. Gotcha, yeah. So if you want to go ahead and open that up, since it takes, 20, 30 minutes to open up Eclipse, you should be there. TJ, I think it's recording. Let me check. Yeah, it's recording. So we got that. All right, so what we're going to talk about, I want to be clear, these are not my slides. They're from this Paul Amon and Jeff Offit, and they're old and they don't need to be updated because this stuff doesn't change very often. And frankly, it's just not, it's kind of like what we would call seminal or foundational. So I didn't bother making my slides. I used some really good slides, and that's what we're going to base our lecture off of. So I don't take any credit for this work. So let's look at, well, let me see for some reason. Let's look at the topic. We're going to talk about software testing. Now, a couple of things that need to be understood is that software defines some behavior that either is related to some real world application or for infrastructure. So things like networking routers, being the infrastructure, things like financial software being some application to some real world process, right? Some business process. But the thing about it is the market now is bigger, competitive, and there are more users. It has software now the word that's used but not used here is ubiquitous. Ubiquitous meaning it is literally everywhere. All right. So since I have my phone in my pocket and my Apple Watch on my wrist, I have at least 2 computers on my person at all times, right? And this is incredible considering the amount of information that's given. I'll step into my car, and my car has at least 4 computers within the car, and I can only imagine how much better it's going to be when my Cybertruck gets delivered. I'll have a couple of great computers in my car. It's just everywhere. I always talk about this. I have a toaster that my mama gave me, and when I make toast in the morning, it goes out and it gets the weather, and it burns a picture of the weather on my toast. So awesome. I love it. All right. But believe me, it's a computer, right? So even my toaster is a computer. So with this ubiquitous nature of computers, it often introduces this other component, which is risk. All right, it's just a huge risk. So a lot of testing is puts pressure on developers these days. It used to be, and I was talking about this later. It used to be that there was like a QA person. But we do agile programming now, right? This cyclical, repetitive thing, and a lot of the testing, it ends up being on the coders themselves. So let's take a step back, and let's have 3 vocabulary words that I will never, ever, ever ask you again, okay? But it is fairly important for just a description of it. So there's 3 things: fault, failures, and errors, all right? So software fault is a static defect in the software. A failure is some sort of external behavior that signifies that there is a fault in your system. And an error is the manifestation. It is in error of that. So a little bit would be like if I've got the COVID-19, right? The COVID-19 virus that is in my body is the fault, right? The failure would be, let's say, coughing, right? Something like that. But the error would be that I have pneumonia, right? So that's kind of those three things. I'm in a different state. I have pneumonia. I'm not well, right? The symptom is the failure. So my coughing, my inability to breathe would be the failure, and the fault would be that I have COVID-19, the virus inside of my body. Maybe not the best, but I tried to use a timely example there. All right, this is a repeat of that. So let's look at a likely error in this piece of code. And this is my bad because I actually meant to, this is on animation, and I can't go full screen and share it on Google Meet, so it kind of highlights what the error in the code is. Here we have a function called num0 that takes in an integer array and returns an integer. It says count equal to 0, and from 1 until the length of the array, if it's that the value at that index is 0, it increments count. Now, this one tells you exactly what the error should be, right? Everybody see it? Now, here's the funny thing about errors. You need to know that this is a fault. This is a fault. Right here where it says int I equals 1. That's probably one of the problems that we have equals, right? Int I is equal to 1. We just kind of overlook a lot of assignment and equality questions. But it says int I is equal to 1. And we've been conditioned to kind of look past this because there's a comparison operator as well. We don't think about the logic behind this assignment. There's a logical error. Okay, I mean, we're using assignment, which is right. But I'm just saying this is why we don't think about this stuff. It's using assignment, which is right. What is truly wrong with setting it equal to 1? And which should the starting point be? 0. It should be 0 because indices are 0-based, arrays are 0-based. And this is Java, right, our comfortable language. But here's the real problem. Here's the issue with this fault. This fault does not always cause a software failure. It doesn't. Here's the problem with it. This only gives you an incorrect answer if the first value in the array, the one at the 0th index, was a 0. Otherwise, it's going to be correct. So let me say that again. If the very first element of this array is non-zero, it'll give you the right answer. Let's think about the practical application of this. The vast majority of the time, it's not going to be 0, right? It's going to be something else. So if you test this code, you may test it 100 times, and it never exhibits a failure. It may never have, but it'll always have a bug in the code. And this is incredibly frustrating. Okay, the longest time I've ever spent finding a bug, it took me about 2 weeks to find a single bug in a piece of code. And I'll tell you what ended up happening is I had this inside of, and I'm going to type it into the chat box here so everybody can see it. I had this. I had if, let's say, server is equal to server status is equal to open and num joined plus plus is less than 10. All right, so I had something like this as a condition in a loop inside of a very intricate algorithm for load balancing in a peer-to-peer network. All right. Does anybody see the problem with this? There's this crazy problem that I didn't know about. And the biggest problem was if I was debugging the software in C++, is this thing, and whenever you compile it, you have your debug level, right? I had it, when I was debugging it, it always worked. When it was out in release, it never worked. And this is what's crazy. It just boggles my mind. In C++, the first condition is if server status equals open. But in the second one, I increment, actually pre-increment num joined, right? Well, if you're a C++ compiler and you're executing this, if this was false, do you even need to evaluate the second condition? This only happens if these both are true. So if the first one didn't evaluate as true, it skipped it, and it skipped my increment. That's kind of cool, huh? I worked about 2 weeks, but it was about 60 or 70 hours per week on one single bug trying to find this single error. The biggest problem is there was a fault in my code that didn't create failures, and that is bananas. It was really, really hard to find something when you can't break it, when you can't see the failure that it causes. So anyway, just a quick example of something from real life. I hope it actually kind of makes it relevant. So bug is an informal term for this. And to be honest, I'll actually use bug a lot because it says, okay, a fault, error, failure, it's there. The slides say this. I don't try to specify. We all know what it means for bug. It means something's wrong. I do like to tell this story. I'm sorry if everybody knows this, but my firstborn child is named after Grace Hopper, Rear Admiral Grace Hopper. She was one of the first people to sort of develop imperative and this sort of high-level programming language. She worked on some of the first digital computers. But she used to work on a NIAC, right? And a NIAC is bigger than this room. And instead of little transistors, it worked on vacuum tubes that are little light bulbs, right? And they would turn on, they heat up. And the way they would do it is they'd organize the circuits to program it before they'd go home at night. And then they would set it to running, and then they'd go home at night, and they'd come back the next day, and they'd take the readouts, and they try to figure out what the calculation was. And one day they came in, and it was the wrong answer. They didn't expect it. And so they went through and they looked, and they feared, and a moth had flown in like moths tend to do, and it found a warm light bulb, one of the vacuum tubes, and it hit the vacuum tube, and it fell, and it shorted out the circuit underneath it, right? And so they actually scrapbooked this moth, and you can Google it, and it says the very first software bug was literally a bug, which I love that, okay? But you can Google it. It's up there. It's the first software bug. So anyway, that's kind of my story. So why do we care? All right. So once again, I hate that this is not the presentation because I don't get my animations. But I want to talk about some of those epic software failures, the ones that I like. And I did change a couple of these, I think, from the source material. But first that we're going to talk about is 1999. Many of you were born that year. I graduated from high school that year, and it was a big deal that the Mars had or NASA had the Mars lander, and that was going to be this big thing that we're going to actually have something on. Now we've got the Mars rover. This is one of the first ones. So we stayed up and watched this, right? We saw that the NASA communication, they had NASA TV on the satellite and everything. It would come down, and we're all watching it, and it's here and it's here, and it gets to the upper atmosphere. And then everybody just gets quiet. And now, the footage is still on YouTube. It's hilarious because one of the engineers goes, what now? It was just like, it went dark and nobody could figure out what was going on. After weeks of testing and trying to figure out what went wrong, they had the funniest of errors. NASA used inches and feet. Their partners used meters. So it was English versus measured. That was the failure. So an entire launch to Mars failed because we tried to American it up a little bit too much. So I don't know. It's one of those interesting things. Now, to go from one of my lighter side ones to this next one is this one that really drives it home to me. For VRAC 25 is a radiation machine. Now,
I don't know if any of you have had skin cancer before, but when I was kind of younger, probably 13 or 14, I developed a skin cancer on my back, and I ended up getting radiation for it. And I'll tell you, it's not a pleasant situation, all right? They kind of come in, they sometimes mark it with like a little tattoo gun, and they put a little mark on it, and you go lay down on your back, and they have this machine, and the machine shoots radiation. I mean, the same radiation like you think of with like nuclear plants, right? It's that kind of radiation. And the concept behind it is they bombard it with this radiation so that it kills the cancerous cells. And it's a little bit like chemotherapy. See, the doctors have this one calculation that they always do, from what I understand, for chemotherapy and radiation. They figure out what a lethal dose is. With chemotherapy, they think about how much of this drug is going to kill you, and then let's dial it back a little bit. That's always one of their first ones. With radiation, they kind of think they have those two sides. What's the minimum effectiveness? What will kill you? And let's find a midpoint. And let's find working there. So it's a really scary thing to go through. But the other thing is it's incredibly painful. Believe me, there's no question that you're getting shot with a laser gun. All right, it burns. You smell a little bit of barbecue. It's kind of weird. Like you smell it and you're like, I am cooking. Like it's totally weird, And I'll never forget the smell of it. It's just weird. I mean, it didn't smell bad, right? It's kind of crazy, all right? So it's, but as I go through it, I make jokes about it. There's this really funny thing. Now, everybody here knows better. Everybody here knows better than what just happened. Even if you didn't take 420. If you are making an online order, have you ever seen the thing that says, don't hit submit twice? Have you ever seen that? We all know, because they say, y'all haven't seen it because people are better than this now. If somebody hits the submit button, what are you supposed to do to that submit button? Gray it out, disable it, right? We know that now because you don't want people double clicking it and submitting it twice. You don't want, no. So what we know now is on click, disable. We know that now. They didn't know that here. So they would have people go into the room that's giving the radiation dose and stand under this THRAC 25 machine that is literally a laser gun pointing lethal radiation at patients, right? And the operator of the machine can't be anywhere near this. So they go into another room with a little camera, no sound, but a little camera to make sure everything is going through. And it's thick because this person's administering radiation. You know, they have to stay safe. Well, they would go in the other room, they'd fill out all the dosage information, and then they'd hit submit. And the submit would administer the dose of radiation. But the designers of the THRAC 25 didn't disable the submit button. So they would double click. And instead of X number of rads, they would get twice that. Or in some cases, and unfortunately 3 of them, they were getting submit, and it wasn't going to the next page. So you had 20 and 30 times, right? Once again, laser gun, burning people, right? This is incredibly painful, and multiple patients died from it because they didn't disable the submit button, right? Insane. But that's how important this stuff is. So for me, kind of my story, and I know you're thinking this will never, ever touch you, right? You just want to go work for CGB. You just want to go work for Invoke. And you want to go develop driver's licenses. You don't want to, you're not going to be doing this. But it's amazing where these intersections happen. My personal connection to this is I went to a conference in Minneapolis, St. Paul, and we went to an evening dinner, and it was like a Native American show where we were learning about the culture of the tribe from the Minneapolis area. So we go to this island, we're watching it, and I'm sitting there and I'm hanging out. There's a super cool guy at the table, and I'm talking to him, and he asked me why I'm here, and then I asked him why he's here, and he's like, oh, I'm here for a QA. And I said, oh, that's kind of a boring topic to come to this conference for. And he's like, oh, I'm from Oregon Scientific. Maybe you don't know. He was the project manager of a pacemaker project. And the pacemaker was flawed. It ended up killing around a dozen people because of the flawed pacemaker. If somebody with an NFC communication device would have the wrong connection in there, it would end up flawing the pace from the pacemaker, and it would send people into cardiac arrest. So just crazy, right? This is a man that's saying, oh, I care about software testing. I accidentally killed a dozen people, right? So it can get really personal really, really quick. So we don't want to dismiss all this stuff. It can be super, super important, even with human life. All right. So Yeah, Northeast blackout. I'm going to scooch through this. All right, so besides human life, what else can be caused? This is super old, 20 years now. I should probably update this at some point. Between 22 and 59 billion annually, I did a report on just errors related to cybersecurity, and that number was like $120 billion. So that was a proposal I did last year. So these numbers are way up. Huge amount of cost. So Amazon in 2006 had a software issue that turned into a double discount, and it hit a lot of websites, and they lost their entire inventory and lost around, I think it was $250 million in about 4 or 5 hours. And they had to honor it because, that's what they sold it for. So we have to be very, very careful. Anyway, time to move on quickly. All right, so I'm going to skip ahead. I don't know, maybe I'm not in a good mood to be teaching this one today. So what is the goal of software testing? So inside of research, let me ask, is there anybody here that might be a PhD one day? Might do grad school? Maybe do grad school, you think? Oh, okay, cool. There's at least one person. I will talk about it very, very shortly then. All right. So there's this process that we call V&V, validation and verification. Validation is ensuring that software has some compliance with what the intended use is going to be. And the verification makes sure that it does what it was established to do in the previous phase. This is incredibly important anytime you do research. And I'm going to say this, if anybody's in security, this is a huge deal right now. It's V&V, all right? It's a little bit like this. You have to verify that your process works, and you have to validate that it should be used. Does that make sense? So you want to make sure you're not creating a solution to a problem that doesn't exist, right? And so you also want to make sure that your solution actually fixes the problem. So that's validation and verification. Two very important words, but mainly for the grad students in here. So let's talk about testing maturity. And I want you to think about this whenever I'm presenting it. I'm going to ask a question, and all the people in Google Meet, I'm going to ask you have to type it into the chat, all right? You have to be honest about where you're at. I'm going to ask you, what level of testing do you actively involve yourself in right now? All right, so it goes like a DEF CON or Orders of Ignorance. If you've ever learned Orders of Ignorance, the most happy you can be is level 0 ignorance. You're ignorant and you don't even know that you're ignorant. You don't know that you don't know, right? And all the way down to you have an awareness that you have an infinite amount of ignorance. It's a lot like that, okay? So we go from level 0 to level 4. Starting at level 0 testing is that testing is the same as debugging, all right? What do I mean by that? We all test a little bit. We're writing up an Eclipse. We hit compile. It seems to not work. It tells us about any static bugs that it finds. We go back and we fix the bug. All we want to do, the only reason we are testing is so that we get the correct result, all right? It doesn't do this one thing. It doesn't try to eliminate risk. It doesn't try to make sure that it's reliable. It doesn't have any sense of security. So we've all been level 0 testers at one point, correct? We can admit that. Inside of 161, our very first homework assignment, when it compiled and it gave us the right answer, you went to Moodle and you hit submit. Done, right? Yeah, I mean, that's what we all do. Who cares? It's a 161 assignment. You may have done that in 390. You may do that in 411. But it's this sort of base level, right? I'm not going to test out whether or not this works in all cases. I'm not going to make sure that there's any security flaws here. I just want to get it done. I want to move on, play Among Us, right? That's what I want to do in my life. I don't want to test, all right? And that's okay to think that way, but it's level 0 when it comes to testing. So how do we get better at testing? How do we move at a level 0? By the way, I want everybody here to at least be better than this right now, is where they're in coding. All right, so let's look at what better is. All right, level 1 takes a different approach. And you're going to think this is crazy when you apply it to level 2. A more mature tester says, you know what, I want to show that my code works. That way, whenever I'm presenting it on 280, like the 285% presentation, have y'all ever like done a little bit extra before your final so that if somebody says something, you can put them in their place? Yeah, okay. A little bit of pride in your work. So testing can go to show that you work. So you add a few more cases. You add a few more accounts. You leave a few blanks in. You try to prove that it is correct. But the only problem is can you ever truly prove that it is 100% correct? Actually, cannot. You can't prove that software is correct. I would love to show you that proof, but that's a little bit, that would take a couple of days, and we're not going to do that. All right? You can show correctness of a very small snippet of code, but for the most part, you can't prove correctness for an entire program. So the problem is this is the error I have. What if there's no failure? There's faults in our code, but we haven't witnessed any failure. What if we haven't coaxed it out the right way? What if it's a problem that only works on the 7th Tuesday of every year? Could happen, right? What happens if it only fails in the state of Arizona? Only fails in the state of Arizona. Y'all know why it might fail in the state of Arizona? They don't have daylight savings time. Did you forget that? Did you forget to test for that? Right? So it's one of those things that can pop up that you never know because you don't see the failure. You didn't drive to Arizona to test it. You may have not known that Arizona doesn't have daylight savings time, right? So how do you catch those failures, right? It is impossible, absolutely impossible to show that there are no failures. So anyway, this is test level 1. I'll be honest, 90% of my code, I'm at level 1. All right, I'm just being straightforward with you. I'm at level 1. Now, level 2 is actually more mature. Remember I said level 1, this is more. Level 1 is so, I'm going to show that my code works. Level 2 is, I'm actually going to try to prove that my code doesn't work. I'm going to try to break it. And that's a good thing. Now, all of the security people, I know there's a couple of security people. I know Tyler knows a good bit about security, right? Oh, okay. I know Craig knows a lot about security. So there's some people here that do that area, all right? That kind of systems administration. If you want to prove that your system is secure, who do you hire to show that it is secure? What's that? Interns, yeah, interns. You hire hackers, right? You say, come break my stuff. Not because you want to prove that it can beat them. No. A lot of people offer rewards for proving that their code is broken. Just show us before you show anybody else, right? Isn't that smart? Isn't that awesome? I mean, it's very smart. I know that I probably am not perfect. It still sounds pompous when I say it that way, but it's saying, right? It's like, I know that I'm probably not. I know that I'm probably not perfect. That should be a given. That should be a given, right? So it's hiring people to go find find the holes in the security, right? Find the places where I didn't make sure that I was secure. And this is a very wonderful approach to risking, because at this point, it's about reducing the amount of risk that your software presents, right? Now let's think back to 285. And once again, I'm not picking on 285. 285 is this great benchmark for which we can be measured. Your user and session management, how secure was it? How sure are you that your session management was secure? Do you think there might have been a flaw in your 285 project if you did a web app? If somebody really tried? Kyle's being very honest. He's like, yeah. See, we may have trusted Google accounts to do our login and session management. Awesome. How much do you know about Google account session management? Could you have had an integration fault on some of the pages? Could you have forgotten an include? Could you have included maybe a developer flag that made it more exposed? How sure are you that your 285 project was secure? Do you feel confident enough that a company should use your 285 code? Or would you want to go back and go, let me take one more look, right? So it's all about making sure that we reduce the risk to the users, all right? And finally, this level 4, I'll just say this, at some point it becomes a discipline that testing and ensuring the quality just becomes who you are as a developer, that you can't see your code as a functional piece of input and output. There's also this insurance of quality throughout that it says, okay, I know that this is working, but how safe is it, all right? And that's sort of that last level is where it's a discipline. So here's the big question, okay? Everybody has to answer. Everybody on Google Meet, listen up. Level 0. I don't know. I just hit compile until it works, and then I hit submit. That's level 0. Level 1. I'm going to try to show that my code is correct. I'm going to try to prove that it is the maximum amount of correctitude, okay? Level 2. I'm actually going to try to find the errors in my code. I'm actually going to try to prove that I'm not perfect. Level 3. I'm sorry, I'm getting myself confused here. Wait, I got mixed. Level 3. All right. Level 3 is about the idea that we're going to reduce the overall risk. And question 4, level 4, is that, it's just I can't separate myself from testing. I don't think anybody's here legitimately at level 4 yet. So, all right, I see a lot of level 1, level 1, level 1, level 1. Teachers at level 0, level 1, awesome. All right, so how about in here? Is anybody level 0? All right, level 1. All right, a lot of level 1s. Level 2s? Oh, Corey and what's you at? Level 1, level 2? For level of testing? 1? Brett, 1? All right. It's a lot of level 1s. All right. So Trevor's like, I try to be level 1. I love that. All right. Oh, 1.1. Trace, I like the 1.1. Just a little bit more. All right. So why does this matter? I'm going to jump ahead of myself a little bit with the PowerPoints. Something used to happen back in the day, and I'll never forget this, and it's changed there. 0 to hero. I love it. All right. So there's this thing that happened like in 2013, 2014, somewhere around there. I went to Blue Cross Blue Shield, and we did a site visit. Very cool campus over there on Bluebonnet and Baton Rouge. Lots of really cool things about it. It was a chill place to work. It was all laptops and VMs, so you could go outside and you could work next to the lake out back. Kind of there's treadmills where you could put your laptop up and walk while you're working. It had all-you-can-eat salad all day. If you haven't noticed, their health insurance, so they really try to keep their people healthy. It's kind of a cool place for me. Only stand-up tables, no meeting rooms where you sat down. It's all focused. That's kind of my thing. I like that stuff, right? But one of the things that I thought was most shocking was we have this meeting and they have a lot of their bigwigs there. And we're talking about their infrastructure so that we can understand what their technology stack is so we can better prepare our students for industry. The Southeastern's jam, right? So we're about developing workforce. So they came in and presented their stack, and about halfway through, this guy came in, and he looked like every 1970s dad, right? Kind of looked like Chunky Tom Selleck. He had this glorious mustache, right? Which just hit. And he has a little halfway bald, and the other one's like a comb over. I can't say too much about it now. Had the pot belly out here, and he had like the light brown slacks and I'm a little bit comparing myself. The fact that it's a full mustache does mean something, okay? And I still have hair down to here, okay? But it was this guy, right? He walked in, and he had his hands in his pockets and his belly poking out. He walked in, and the mood of the room sunk. It was like the Grinch had come in to steal Christmas. And everybody just kind of stopped talking, and they were quiet. Y'all know what his job was? He was the vice president in charge of quality assurance. He was the guy in charge of testing. And everybody in the room hated his guts. He was Mr. No. He was the one that came in and halted progress. He was the one that everybody hated him because they couldn't do anything because that jerk would stop and wait, and they'd have to go through 3 months of testing with people they didn't think, and all they wanted, and he'd come in and he'd say that they sucked, and he'd come in and say their code sucked, and he'd come in and say the whole company should just burn. That was the aura that he gave off. He was the Grinch, and he was the tester, right? This is like the reality of some people when it comes to testing, right? And I'll be honest, a lot of people here would probably feel the same way. I said it previously. How would y'all feel if I asked you, just give me a piece of code and I'm going to put it up on the board? Give me your work and I'm going to put it on the board right now. Would you feel naked? Would you feel exposed? Have you ever butt dialed somebody and just left it on and they listened to you for 30 minutes and you were in the car alone and you were singing and you know what you were singing and you feel horrible afterwards? It's that, right? Everything you do is exposed. Now, how confident are you, right? How I feel naked when people see my code. I don't like looking at people look at my code. I'd rather them look at it and then email me later about it. I know it sounds crazy, but it's my thing, right? So it feels weird, and I think we would probably all feel that weird. I don't think anybody here wants me to open up their homework assignments right now and criticize you in front of everybody else, right? But that's what happens in some of these industries. So testing has a weird aura about it, right? So I actually like the way testing is now. Who's responsible for testing these days? The developers. The developers are kind of responsible for the QA and testing. There's QA and development. It's all kind of integrated. It's all kind of the same thing now. So that's why we have to talk about it here. All right. Let's skip ahead because I want to show some stuff. I'm sorry. I just want to skip ahead. All right. So I'm going to tell you something that's like totally true about testing. And we're actually going to accomplish some testing today, right? We're going to see what testing looks like today. Testing is expensive. When you look at how much a developer makes, most of you are going to go out and you're going to make around 60, 65 if you're developers. You're working 40-hour weeks. If you don't include any vacations, any sick leave, you don't include any benefits at all, then that's about 30, 31 bucks an hour, right? That's if you're just right through, 30 bucks an hour. So when you go to the bathroom for 2 minutes, there's a cost associated with it, right? You just cost your company $1. Exactly $1 to go pee, all right? Now, imagine the cost that adds up when you write a simple function that is 10 lines long, and you spent an hour writing a little unit test just to make sure that that function was right. You need to understand that it essentially doubled the cost of employing you. Your productivity, the time you spent actually coding, you doubled that amount of coding and therefore doubled the cost of having this as a developer. It is extraordinarily expensive. Extraordinarily expensive. But you have to understand that as expensive as testing is, not testing is way more expensive than testing. All right? So the earlier we catch bugs, the cheaper they are. Now, out of this entire PowerPoint, I will tell you the honest truth. I'm probably not going to ask you hardly any questions from this entire presentation on the exam. I look back and I think about it. I'm not going to ask you level 0, 1, 2, 3, or 4. That sounds like a good bonus question. What level of testing are you at and why? And do you want to be better? That would be a great bonus question. And those of you that know me well probably jotted that down real quick so that you You might know that for the first test. More than likely, the first bonus question is going to be what level of testing you're at and why. And so I'm just saying, this slide is one of the things that will show up. I'll probably ask a question, why do we test? Now, there's a couple of things here. This is a bar chart where on the x-axis, you see the phases of development for a waterfall life cycle, which doesn't, apply well to agile development. But this is an application of fault origin and cost to the waterfall life cycle. And in the black or gray there, you have the percentage of bugs that were introduced into a software system. In the green, you see how many of those faults, through the bugs in the software. The green shows what percentage of those bugs were caught at that phase. And the red is the cost per bug for each bug that's found at that phase. Okay? So and I know that screws up the y-axis, okay? The y-axis is the percentage except for red. And red is not necessarily percent. It's actually. So, all right. So let's look at this. In the requirements analysis and elicitation, something we pass over, we are sitting here talking to clients. Tell us what this system is supposed to do. Now, there's probably some big issues with this because every now and then the client forgets to tell you something or you forget to ask them. There's some exceptional case it isn't going to be right. You might not have a business process for it, but there are some problems that can come up. But what you'll see is that about 10% of your total bugs in your system are actually bad requirements. But the good thing is a significant number of these, in fact, 60% of them, are caught during requirements analysis. So in fact, only a very few bugs come from requirements analysis if we spend some time on it. But the best thing about it is it doesn't cost anything because that's the job of requirements gathering. So the cost of finding those bugs is very little. Now, the same thing when you're designing it, when you're creating the UML documents, right? Actually, there's a lot of bugs that come from the UML documents because these are the engineers. The engineers don't have to write the code, so they write some bad diagrams. But, they find some of them, but once again, look at the red. It costs very little to fix bugs at this stage. Very, very little to fix bugs at this stage. Even though we're catching about a third of them that were introduced in design. Now, programming, it says programming and unit testing. I'm going to show you what unit testing is today inside of Eclipse. But during the programming implementation phase, as you can imagine, this is where a lot of the bugs come from. And we only find, once again, a little bit more than a third of the bugs in there. But look at the cost to fix these bugs. Now, after we're done, phases 1, 2, and 3 there, requirements analysis, design, and programming. After that, we have testing and deployment. Once we've kind of done the implementation and we send it to QA, which doesn't really exist too much these days, you won't have any new bugs. You notice the gray bars go away because we're not going to have any new bugs that are introduced during testing. But when we do the integration test, we find a lot of those bugs and the cost goes up. Why? Because you're going to have to pull in developers that have moved on to fix these bugs and return it back. The cost of fixing bugs has now essentially been 10 times what it was when you were developing it. 10 times the cost. Systems testing, this is the last thing you do before you send it out of the door. These are the things that break builds and you have to go back and you have to do, this is bad stuff. The cost triples from even integration testing. But the biggest problem you have is once you've said, okay, I think we've got most of them, there might be only a few bugs that are left in the system. But the cost of these bugs is astronomical, right? Absolutely astronomical. Per bug, you're going to see that essentially you're at 6 times the cost of preventing these bugs from being out there. Now, this is from 2 things. The cost of fixing the bug, but also the risk that it presents to your customers. So why do we test? Why do we test early and often? And it's a single word that has 4 letters. Cost. That's it. Starts off the PowerPoint. All right. Now, I know that a couple people are probably like, Cost or late? Which one? Cost or late? No, it's cost. Okay, so when I ask that, it's going to be cost. All right, so just ask CD Project Red how much bugs are costing them. Oh, absolutely. Yeah, so I was one of the people that I have a PS4 Pro, and I was so happy when Cyberpunk came out, and it was unplayable on the PS4 Pro. It was really bad. So we ended up doing the refund and getting it back. So, and there were some other problems with it besides that. So yeah, I mean that killed off one of the most hyped games. The bugs killed off one of the most hyped games in recent memory. I'll be honest with you, TJ. I don't know the entire story behind CD Projekt Red, so I don't 100% know who that is. Oh, that is Cyberpunk 2077. That's how much. That's how little I know. So, all right. So, what is the overall goal? The overall goal is to eliminate faults as early as possible, improve quality, reduce costs, reduce risk, and make sure that we have a good amount of customers. All right, so that was a lecture I had to get through. So who wants to see what a unit test actually looks like? Let's actually do some real stuff. All right, so I'm going to open up Eclipse here. Wow. All right, so I am going to set up a Java project inside of Package Explorer. I'm not going to use packages or anything like that. I'm going to create a new Java class. Now, we all know how this works. So I'm going to do one called concatenator. And I'm not going to have a main method inside of it. Okay, so I'm going to hit finish without the main, and it's going to give a default class here. And inside of it, I'm going to make a sort of a basic function. All right, so how do we test such a simple method? How do we test such a simple method? Now, I'll tell you how I would do it if I was really at level 0, I guess. The problem is imagine if you had a big group. A big group. By the way, can you see this on Google Meet? Can you see the the Eclipse window? Awesome. Very cool. All right, so I'll tell you the way that I do it if I don't know about unit testing. What I do is this. Public, static, void, main, string, res, right? Does this look familiar? And then you do this. You do like system.out, print line, and then you do like something like this. Concatenate hello, and then world. Right? I would do something like this. And it's got, and I think I spelled it right, it's got a little error in there. And I don't know for sure, but I'm betting the error says something about the word static. I'm not sure. Cannot make a static reference to a non-static. Do y'all know how to fix this? Yes! Tyler says the most horrible correct answer that I hate is right, and I hate Tyler for being right. But we have to just add the word static there, and it works.
Is that really right? Because I forgot what it was.
No. Oh, it is. No, you gave me the right answer.
I
It just.
like it works, so.
Yes, it is the right answer that is morally and intellectually wrong for so many levels. You gave me the perfect answer, Tyler. I'm being genuine. This is the way you fix it. You can't do it another way because think of it this way. The main function is the external entry point to our application. When we hit go, when we run Java on this class, it knows to start there. And in order for it to be there, it needs to be static. I don't think that it would work. I might be wrong because they've updated Java. But it will work. Okay, so my bad. But we have to do all these things where it's, no, I don't know. I don't think that will work. I think there's going to be problems if I do that. So we have to start altering our code and trying to get it working. What we come is with is this ad hoc solution. I want to get, so I'm on a team with Tyler, and Tyler's developing his application. And I'm over here making a library for him for his string functions. And what I've done is I've created a class that is now executable, right? It's meant to be run. It has a main method. So before I have to give it to Tyler, you know what I'm going to have to do? I'm going to have to do this. I'm going to have to delete this. I'm going to fix it like this. And then I'm going to give it to Tyler. And my testing code is no longer there, right? But hey, if you want to check it out, just run it here. This is all bad. All of this, everything that I'm showing you is horrible. Everything that I'm showing you is just ridiculous, right? If I want to create a class called concatenator and I want to test it, I don't put a main method there, all right? There's just all kinds of bad, all kinds of bad. What I want to do is I want to create something called a unit test. I've made a class called concatenator that gives a bunch of different ways to concatenate strings. I want to test that. So this is what I do instead. I go over here to my project and I right click on my project and I do a new, and there's this thing at the bottom, JUnit test case. In your Eclipse, it is entirely possible that this is in fact the first item on your new list. All right, depending on which Eclipse version you're using, it might be all the way at the top. So I'm going to include this Java JUnit testing. Now, what comes up is a wizard, right, to allow us to create it. I never use JUnit Jupyter. I go back down to 3 or 4. So I'm going to switch over to 4. And I'm going to put in a new name. And the way that we write them is always we start with the word test with a capital T because classes are in capital camel case, right? The hashtag rules, but starts with a capital letter. And I'm going to do test concatenator, all right? And that's kind of our naming convention there that we're going to use. We're not going to do anything else. We're just going to hit finish. Yes, we're going to add JUnit library to our build path, but now we've got this, okay? Now, what we have is this crazy thing, and we'll talk about it again on Thursday. We have this new class. We have in our package explorer, inside of source, we have concatenate, and we have test concatenator.java. And right at the top, there's an include for JUnit and what insertions mean. But everything else is sort of, it's gonna be hard to describe the framework. It's a very little piece of code. But check this out. I can have a test function. Right? And I can do this. I can set up a concatenator. So what I can do is I can do like this. Let me change a couple of things real quick. I can do this. String S1 is equal to hello. Jello. Nope, I'm keeping it. It's too good of a typo. All right, Jello. String S2 is equal to pudding. Went from hello world to Jello pudding. I like that. And then we finally do something like this. Check this out. Assert equals Oh, it's hard to type when you're standing up. I don't know how Dr. Ache does that. I need to be sitting down when I'm typing. Assert equals, and then we're going to do yellow pudding and concatenator dot concatenate S1 and S2. Oh, that's S1 and S1. All right. So this is what's kind of funny. What I just created was a test function where it's called test base concatenation. I set up two strings inside of this function, and then I call the concatenator's method for concatenate with the S1 and S2. And this function, assert equals, is a special function that tests whether or not this first parameter and this second parameter are equal. In another way to say this is it's checking to make sure these two things are the same, because this is what I expect the result to be, and this is the function I'm testing. I'm testing out the concatenator's concatenate function. So let me show you what it looks like. We go over here and we do run, and we do run. Yes, let's run that. Okay. And it changes the perspective. Now, it's still the Java perspective, but it creates a new window on the left-hand side. The Package Explorer goes away, and now we have the JUnit panel. The JUnit panel I usually leave over here. And so now I have my Package Explorer and my JUnit panel. And check this out. I have a test run where it says the test concatenator, and that little green bar says we need to pass that test. This is really cool in some ways. Let me show you what can change here. I can go back to concatenator, and I can do, well, I know better. I wanted to put a space there. So this is going to give me Jello pudding with the space. All right, we hit run again. And it turns out red on our JUnit test case. It tells us that there was a flaw between what we expected to happen and what happened. I don't feel like I'm adequately expressing exactly how cool this is, because on this we can see where the failed case, test case was. We can double click on it. It highlights what it is. We can go to this, one of these, compare result, and it tells us that what it expected was Jello pudding without a space, and what the actual was Jello pudding with a space. It gives us so much functionality here, right? Now, you might be asking, why is this important? Why is this important? Let me do another class here. This class is going to be called driver. It's going to have a main method, and inside a main, I'm going to have the same stuff that test concatenator did. And now we're going to see a couple of different things. I'm going to kill off my JUnit test panel here. Now, if I do run, I can click here and run it. I can run as either a Java application or a JUnit test case. When I do Java application, everybody knows exactly what happens. When I do run as an application, it goes to the external entry point, which is public static void main string bracket args, right? And it runs the code, and it prints out Jello pudding. It runs this code. But what it doesn't do is it doesn't run this test case. If I go up here to the top and I click on the run as, I can switch to run as a JUnit test. And now it'll open up that perspective and say, wait, we had a failure that we didn't expect. There's a subtle difference here, right? Depending on how we run it, we either run it as a JUnit test suite, and we get whether or not it passes or fails some test cases. We can run it as a Java application, and it'll run the application. Do you see how that could be better? The opposite is for something like this. Inside of our driver, we would have something like this. Anybody have a printout like this, and you run it inside of your code to quote debug it? Should be jello pudding, was jello pudding. So then you fix it, and then you comment it out. And the way you save off your test cases, you have all the comments there, right? I mean, that's the way we do it. And I mean, I still do it that way. We all do it that way, especially in competitive coding. We do it all the time. But this is a little bit kludgy. When you run a test case, it doesn't go to main. It absolutely doesn't go to main. It goes to the test cases and it runs them over. All right, so not runs them over. So let's try some what it can do really interestingly. All right, you can have multiple test cases inside of here. You just test empty concatenation. You can have another one. Wait, oh yes. You know, all of these different test cases that do different things, and it'll run them each as a suite. So let's see. Right? We run the suite. I actually have to do this. Run as a JUnit test case. And it says we failed all three. Failed all three. I actually wanted one of them to work. We have to check what each one of them is. See, for this one, we compare the results. We're getting rid of the spaces. So I'm actually going to try to add 2 of the spaces just to see something. Run as a test case. Wow, is it still not any of them? All right, look, it says it passed 2 and failed 1 of them. So so you see what's going on here? We're actually able to test out these functions without having any sort of leftover code in the middle. All right. So I hope this kind of at least showed how unit testing works. I feel like I didn't do it justice here. I don't know, I wasn't my day for explaining how this works. But there's a real beauty to this, all right? It's a new sort of tool that we have for making sure our code works. When we go over this tomorrow, what we're going to be looking at is we're going to be looking at a way that we can create these test cases as specifications. Because there's this weird thing. Like, where do we get test cases from? From the UML lecture, where do we get test cases from? What's the unifying design of all UML? That base diagram that was so important. Yeah, user stories or use cases, absolutely. That's where we get them from, okay? We're going to start with these test cases, and we're going to develop each piece of code around the test cases. And so it's going to, I promise, it will be very interesting and fun to about 3 of you, okay? It'll be life-changing to 3 of you, okay? So it is interesting, but we're going to come in, we're going to code, and we're going to start off with some challenges. And we're getting back to that deductive thinking with Sherlock Holmes. It's really, really fun. I genuinely enjoy it on Thursday. It's one of my favorite topics to cover. So make sure that you're here. Any questions from today? Wait, I want to make sure that I'm clear that you don't have to be here. I do think it would be a good day to be in class. Might not be 100% compliant. We might have people with laptops be around the front or something like that. But it would be cool if you could, but not required. You can be at home. It's just a good day to be there. I don't want you to miss it. The next homework assignment is test-driven development. On the test, both the midterm and the final, there will be test-driven development questions. Right, so you want to be here. Not physically, but. All right, that's it. That's all I've got. Yeah, Trevor, absolutely. I'll do that for you. Well, what I want to do is I want to do it like I meant to do it, which is to take out the space. There we go. I've scratched your itch, man. Failure trace. Let's see. What's failure trace mean? Failure list. That's funny. Yeah, absolutely, Sylvan. We definitely will.